Kristine, this is Rick, and I'm going to try to respond to your email questions that you sent me about this question from the book. I haven't watched the video, but I do think that I can answer your questions about all three parts for part B, and then all three parts again, A, B, and C. So what I actually have on here is copied the null and alternative hypothesis, the n, and then the alpha value. We do have this X bar sample mean in part A of 103, and they give us in part A the standard deviation of 11.5. So I calculate the t observed statistic by taking the X bar minus the hypothesized mean divided by S divided by the the square root of n. That's the standard error. So this difference between the means divided by the standard error, and you get the same thing, the 2.1032 that you have referenced over here. So the next part of this now, and this is where I was doing something else, and now we want to actually turn this into a p-value. All right, so I first need to notice that I'm actually doing a two-tailed test. So what I want to know is the probability of getting a score that's more extreme than the one that I observed on the sampling distribution. So this is a 2.103, it's up over here. And so what I'm going to do is find the area that's beyond that. And I want to find the area that's beyond it on the other side, negative 2.103, because these are symmetric. And I want to add those together. But it actually suffices to find one of these and then to multiply by 2. So in order to find this area right here, I can either look it up on a table, that has the right, but most of the tables are going to have the left area, and that's why you get the 1 minus, because you want the right area from this positive t value. So if the table is giving you the left area, you do the 1 minus to get the right area. And so let me show you how that works in Excel. So instead of doing a table lookup, Excel is going to do the same thing. So I'm going to feed it this t value, and I'm going to do the t distribution, and it'll give me the total accumulated area up to, on the left, up to 2.103. All right, so I'm going to do equals t dot dist, okay, the left-tailed student's t distribution, and then I'm going to give it the x value, which is our t value, 2.103. And I'm going to give it the degrees of freedom, which is n minus 1, so that's 64. And I'm going to say cumulative true. I'm accumulating all of the area up to this value. So that's going to give me the left area. But what I really want is the right area, and then to double it. Right? So if I just press enter, that gives me the left area. And so now I can either on that line or on a different line, I can do equals 1 minus that left area. That gives me the right area. And then my p-value is going to equal just double that. 2 times 0.199702 to get that p-value of 0.039403. And I think that kind of matches, up to a decimal or something, what you have over here. So the reason why they did the 1 minus in this case is because we had a positive t value, and this t distribution Excel command is giving us the left area. And because we had a positive t value, we wanted the right area because those are the ones that are more extreme. Now, when we get down to part B and you do this t observed value, this test statistic is negative, right? So why is it that you don't do the 1 minus in part B? Well, it's because in part B, you have the same picture, the same kind of t distribution, but you have a negative t value. Negative t value is negative 2.56. So if I find the left area, that's the one that I want. That's more extreme, is the left area here. And so then I can just kind of find the plus 2.56 as the doubled part. Right? So I can find the left area without doing the 1 minus. because Excel always does left, with a caveat. So, for part B, now I would do equal t dot dist and feed it the negative 2 point whatever, 2.56526, 2.5256. Hope that that's right. 56256. 56526. 56526 with 64 degrees of freedom cumulative true. And here's that left area. And then again, because it's a two-tail test in part B, now I'm going to double it. Equals 2 times that number. And that gives us our p-value of 0.012, which is what you have written over here. So again, the reason why we don't do the 1 minus is because our t-value is negative, and Excel always gives us left area. If you go back down to part C, now you get a positive test statistic. So I need to do the 1 minus to get the above area and then double it in order to find my p-value. All right, well, I hope that helps. I don't use tables. You can find these things online. I used to have some laminated copy that I would bring into the classroom and hand out to students. They're also usually in the appendix of the book. You might go into your ebook and search for the appendix, because they often have these normal and t tables in the appendix of the book. Not exactly sure if they're in your book or not. But again, I'm using Excel these days to calculate those instead of looking them up in a table. All right, I hope you have a great day, and I hope that this has been helpful. Instead of posting, well, I'm going to try to send it to you, but I may also post it on YouTube in case the file size is too large. Have a good day.